Alright, so in this video we're going to show you how to retrieve your encoder temperature using a Kinetix Servo drive. Now this servo drive can be, again, anything that uses a Hyperface encoder, so a Stegman Hyperface encoder. If it uses a resolver or something of that nature, it will not be able to be used. So keep in mind there are some limitations about this, but it has to be a Stegman absolute encoder. Okay, so that's used with the Kinetix 6000 drive, or in my case 6000, but you can use this with the 5700s, the 5500s. You can use this via SIP motion, again with the 6200. But it basically rolls down to having the right Hyperface encoder, right? And that's Hyperface Stegman encoder. Again, that's going to be generally, that's the base implementation of newer stuff nowadays. So this is going to be showing you how to do that. At the current time, you see I have it equated down to my Fahrenheit, because what this does is it reads in Celsius. So keep that in mind. So all this is doing, and I'm going to blow this up just so you can see it a little bit better. So let's actually go in here and actually zoom in just a little bit so you can see the code a little bit better. Alright, so now you should be able to see the code really good. Alright, so I'm basically, if I come in here and toggle this bit, everything goes high, right? And it will read that specific servo drive. My specific servo drive right now is, again, and I'll pull this up just so you can see this, the actual setup, is a 2094 BCO1. Again, that is basically a power supply and a servo drive, Kinetix 6000, and again it's running a 460 volt. So, and again, this is my trainer servo. That's exactly what I'm actually using. I'm using a real world servo drive for this, so you can actually see the motor is actually in MPL-B310, right? So this is actually showing a Hyperface encoder. This is the reason I wanted to show this, because again, it's a very powerful tool to make sure you troubleshoot your systems correctly, right? So again, how does the code work? So basically we have a simple timer. When the timer is done, it issues a message instruction. I'm going to show you in the message instruction what it does. Okay, so we're going to pop this open. Alright, so it needs to be set to the proper thing. Alright, so according to the Rockwell documentation, your message type will be a Sercos in, and that will be a Sercos in read. Again, that is if you're using a Sercos system. When it comes down to it, again, if you're using a SIP, your SIP will change, right? So if you're using, I'm using a Sercos. So in my application, I'm using Sercos network, so I'm going to use a Sercos in, right? In your case, if you were using a SIP motion, you would change to a SIP motion. And again, that would be a SIP generic. Okay, so make sure you know that would be a SIP generic. Now, I am showing where I'm pulling the data, and the data I'm pulling is from is P, so you can change this from S to P. Default comes in as an S. We want to actually get that, so we're changing it to a P. Now I'm reading 302, and I'm getting the value is in the operational value. I'm getting the current operational value, and this is going to be a data type of integer. Okay. So in this, you don't have to make your dent that big, but what I did is I made a very simple dent, and this dent could be actually made it big enough to where I could do whatever I want to with, but you only need one. But in this instance, I made it as big as I want to because I'm loading it against itself right here, just to show that the value does work. So in that case, you come down here in communications. If you were SIP motion, you would point to your SIP drive over in your configuration. In my situation, I was pointing directly to my actual servo. This is the servo that I'm using, again, when it comes down to using this with Sercos. So again, this application is using it, I'm showing this using as in Sercos. If you're using it in SIP motion, again, I will show you how to set that up in a separate video. But again, when it comes down to it, this is how you read it. So as my message comes done, you can see the done timer comes on. It comes over here, the message is done. Then it comes in here and reads the value. Now, what does this actually do down here? Like I said before, it reads in Celcius. So you're getting the actual information in Celsius. So if you're in America, or you want to just read in Fahrenheit instead of Celsius, then you would actually use this formula right here, which is basically the component, which is the component you want to convert to Celsius or convert to Fahrenheit. Then you would actually use that times 9 divided by 5. And then after the equation is finished on that, again, order of operations, that's why we put it in brackets. You can easily see that. That's why we put it in brackets. Then we're going to add 32 to that. That is going to be my actual readout. My actual readout of this servo motor right now is going to be 80 or 78. Right? So let's just say, what if I were to actually run the motor? All right? So I have something setting on top of it right now, so let me actually move that so I can actually run the motor, and then we can change the actual temperature. Let's see. So let's go to Motion Access Direct Commands, and let's turn the servo on, and then we'll come over to jog, and let's see if we can't change the motor temperature real quick. So we'll put a speed of 10 in, and this is just a standard jog. Okay, so this is actually jogging. So let's see, as it runs, let's see how fast. Now I don't have an actual load for this. All I have is just a regular wheel that I purchased from I believe a cheap, just all it is like a regular wheel you would put like on a, I believe it's like a, something I got from Harbor Freight or something. Anyway, it's real cheap and real simple. I just put it on top of it. What I want to do is actually run this to see if I can actually get this speed. Let's just change the speed, see if I can get it to a different Fahrenheit. So, and it may take a minute to actually do that. So let's actually run this for just a second, and I'll pause the video and come back to see if we can't get this a little bit higher. All right, as we're running this, I was able to get it a little bit higher. Now again, I'm running it on. I have this servo specifically wired in and it's running pretty fast too. But I have this servo specifically wired to run off a 110 system, so I have it in demo mode. I have the actual Kinetix 6000 in a demo mode, so it is running off 110. So this servo is rated for 480, and I'm running it off 110. I was able to run it at full speed, which is the way I have the attributes of the servo is speed of 30, and you can see the Fahrenheit did go up slightly. Now the longer I run it, the longer it will. Now again, this servo is really healthy, so I don't have an actual problem with it. But you would have this servo control, or this actual monitoring control system in your system to monitor if the servo has a mechanical wear to it, like say the bearings are going out, or you have some kind of heavy load on it where there is a specific point of failure that you're trying to monitor, right? So this is why this code is so powerful. Now again, when I actually am showing this in a Sercos model, but again, when it comes down to it, this is reading the actual parameter for the actual encoder. Now let's actually change this down, because I'm not reading the windings. I'm not reading how hot the motor is itself. I'm reading the encoder, because the number one thing that fails on these these motors is the encoder, because the encoder gets hot enough where it faults out. Again, so let's change the speed a little bit down, so you can so I can actually talk a little bit, because it was a little bit, you might not could hear it, but it was a little bit loud in my ear. And you can see the Fahrenheit did go up just a little bit on that. So just changing the speed on this as well. Let's get it to run 5. And it just basically what that's doing is, and when it's having to go from a high speed to a high inertia to drop it down, it's basically increasing that the torque on that motor, and that motor's torque is converting to heat, and that heat is converting again through the windings to the actual encoder inside the motor. So that's just showing you a simple illustration. Now I'm using, again, my setup is real simple. It's just a motor with a wheel on top of it. Literally a wheel that you get off a wheelbarrow. That is what is on top of it. But I have it highly secured so it won't go nowhere. Again, so let's actually stop this, and let's go to a controlled stop and stop all. So we'll stop this and we'll turn it off. And hopefully this was a very educational and helpful video for you. As you see, the Fahrenheit did go up when I stopped it again. That is because of the load and the torque behind that when you torque and have to start, start all the time, the torque does go up on these motors, and the torque will convert to heat. Keep that in mind. That is why this is such a powerful tool. And again, I'm using this directly off of the knowledge base setup. This again is a Sercos based system. So when it is said and done, you would change to a different. Let's just actually show that real quick. Let's show the atmosphere, and we did a message, and let's just say we did a message and we came down and changed the message. This is an input, so let's change the message to I just want to show you this example message, example CIP, and then we'll get that and we'll call this, and we'll basically let's make that instruction. Come over here, pop this open. You would change to a generic SIP just like it is, and you would come down here, and then in here you would get a single attribute. So you would get attribute single. So get attribute single. You'd come over here, and then you would get 42 is what the tech note says. And I will link the tech note below for those that do have knowledge base, just so you have the references that I have. And then again, you would put your tag right here. Again, if you had it, and then again in the path, you would pick your SIP motion path. SIP motion again is Ethernet driven servos and controls and stuff of that nature. So again, when it comes down to it, this actual training setup I have is not a SIP motion. So unfortunately, I'm not going to be able to show you this connection working live. Just wanted to show you the quick parameters and what you should use. Again, this tag should just be the same as the other one. As far as the integer or the dent, I would use a dent in this case. So with that said, hopefully that was a helpful video, and hopefully that showed you. I'm going to delete this one because again, we're not using it. Again, when it comes down to it, we are using a Sercos system, so we're using a Sercos read, and the data that we're reading is from the actual encoder. So hopefully that was helpful, and we'll see you guys on the next one.